Hello everyone. So this is a question from JEE Mains 2026, 28 Jan evening, and you can pause your screen and go through the question. So um, in this question, so the following statements about manganate and permanganate ions. Okay, so they have given some statements about them and identify the correct statement. So we have to identify the correct statement. Okay, so the first one is the geometry of both manganate and permanganate ions is tetrahedral. So they are asking about geometry. Okay, oxidation states of manganese in manganate and permanganate are +7 +6 respectively. Okay, then oxidation of Mn+2 salt by peroxo disulfate gives manganate ion as the final product. Okay, then manganate ion is paramagnetic and permanganate ion is diamagnetic, and the last one is acidic permanganate ion reduces oxalate, nitrite and iodide ion. So we have to tell how many of them are correct. Okay, and the chapters involved are DNF block and redox. Okay, so before we start, we should know what are manganate and permanganate ions. Okay, so manganate is MnO4 2 minus, so this is manganate, and MnO4 minus is permanganate. Okay, this is the prerequisite. We need to know what are these. So potassium permanganate is KMnO4, potassium manganate is K2MnO4. Okay, so you must have heard about them while going through DNF block. Okay, so let us look at the first statement. The geometry of both manganate and permanganate ions is tetrahedral. Okay, so manganate ion looks something like this. So it will have the structure of manganate ion is like this. So Mn double bond O, single bond O minus, single bond O minus. So this is the structure of manganate ion, MnO4 2 minus, and this is tetrahedral. You can see there are 4 bond pairs and like there are no lone pairs. Okay, so this is, so geometry is tetrahedral. For geometry, we just need to know how many bond pairs are there. Okay, so it is tetrahedral. And permanganate looks like this. Mn double bond O, double bond O, double bond O, and single bond O, and with a negative charge. So this is what the permanganate ion looks like. That is MnO4 minus, and this is also tetrahedral. As you can see, there are 1, 2, 3, 4 bond pairs, and in VSEPR theory, always remember the double bond is considered as one bond for determining the shape or geometry. Okay, cool. So the first statement is correct. So this is true. This is a true statement. The second one, the oxidation states of Mn in manganate and permanganate. Okay, so we have to calculate the oxidation state. So let's calculate in manganate, MnO4 2 minus. So assume Mn as X. We know oxygen, it is -2, so +4 into -2. There are 4 atoms of oxygen and total charge is -2. So equate it to -2. So X will come out to be -2 plus 8, that is +6. And to calculate for permanganate, that is MnO4 minus, assume Mn as X. We know for oxygen it is -2 and there are 4 atoms of oxygen. So 4 into -2 is equal to total charge is -1. So -1. So X is equal to -1 plus 8, that is +7. So in permanganate it is +7, manganate it is +6. So in manganate it is +6, permanganate it is +7. Okay, but in the statement you can see they're saying oxidation states of Mn in manganate is +7 and permanganate is +6. So this is false. This is a false statement. Okay, third one, oxidation of Mn2 salt by peroxo disulfate gives manganate ion as the final product. If you have gone through NCRT of DNF block, this is one of the methods to prepare permanganate. Okay, so Mn2 salt, so let us represent Mn2 salts like this. So these are Mn+2 salts, and peroxo disulfate is S2O8 2 minus. So this is a method of preparation, lab method of preparation of permanganate, not manganate, and water will be there obviously. When this reaction happens, we get permanganate, that is MnO4 minus and sulfate. SO4 2 minus and H plus ions. This is the reaction. So obviously this is not balanced, we can balance it, but according to the statement, what are they saying? The statement is saying oxidation of Mn2 salt by peroxo disulfate gives manganate. No, it gives permanganate. So this is false. So this is a false statement. It gives us permanganate. Okay. Next, manganate ion is paramagnetic and permanganate ion is diamagnetic. So we have to, so let's talk about manganate, that is MnO4 2 minus. We know here the oxidation state of Mn is, we just calculated it is +6. Okay. We know the configuration of manganese in the ground state, so that is 3d5 4s2. Okay. And so what will be the configuration for Mn +6 in manganate? So we have to remove 6 electrons. Always start from the outermost shell. So remove 2 from here, remove 4 from here. So we'll be left with 3d1. So we'll be left with 3d1. Okay. And you can see there is one unpaired electron. So therefore, because of the presence of unpaired electron, it is going to be paramagnetic. Okay. So therefore, manganate is paramagnetic. Correct. Next, permanganate. Permanganate is MnO4 minus. Okay. And here the oxidation state of Mn is, we know it is +7. We have just calculated it. And so we know the ground state configuration of manganese is 3d5 4s2. So what will be the configuration of Mn +7? So it is going to be 3d0. And you can see there are no unpaired electrons. So therefore it is going to be diamagnetic. Okay. So therefore let us look at the statement, that is manganate is paramagnetic, correct. Permanganate is diamagnetic, correct. Okay. So this is true. And let's look at the last statement. Acidified permanganate reduces oxalate, nitrite and iodide. Guys, acidified permanganate is one of the most common and strongest oxidizing agent. Why will it reduce? Why will it reduce? So at the first instance only, this is going to be false. Okay. It is a very, very strong oxidizing agent. It, oxidizes your oxalate into carbon dioxide, nitrite into nitrate, and iodide into iodine. Okay. So if you go through the NCERT of DNF block, you will see that there are certain reactions where it acts as a very strong oxidizing agent, MnO4 minus. It reacts with oxalate, that is C2O4 2 minus, and it converts this into CO2. It reacts with nitrite, that is NO2 minus, and it converts it to nitrate, NO3 minus. It reacts with iodide, that is I minus, and convert it into iodine. Okay. So this is an oxidizing agent. So therefore it will oxidize this guy into CO2, oxidize NO2 minus into NO3, oxidize I minus into iodine, and it will itself undergo reduction. Itself undergoes reduction. Okay. So therefore the last statement, that is, acidified permanganate ion reduces, that is incorrect. It is false. So therefore statement A and statement D are the only correct statements, A and D. Okay. Thank you.